Alright, we are being told to find angle beta, the angle between vectors u and vector w. And to do this, we are going to use this formula. There's more than one way that you could solve this problem, but specifically we want to practice using this formula today. This formula has in the numerator the dot product, and in the denominator we have normal multiplication. So we need to be very careful about how we move through this formula and do the right operations in the right places. Before I get started into doing this, I'd like to sketch, first of all, what these vectors look like and exactly what we're looking for with this angle beta. Alright, when we look at our sketch, we have vector u over here, vector w over here. We're trying to find this angle in here. This is our missing angle. So I'm going to do the walkthrough of this formula in steps to help myself keep track of things. It's something that might be useful to you as well to help you keep track of things. As a step-by-step walkthrough, I'm just going to make a list of calculations and then plug them in when I'm done. So I want to calculate the numerator, which is the dot product of the two vectors. I need to find the magnitude of vector u, and I need to find the magnitude of vector w. So these are side calculations that I'm going to make ahead of time so that I can plug them into my formula. So the dot product of u and w, we multiply the first terms in the component forms and then add them to the product of the second terms. So this is normal multiplication plus normal multiplication. This is going to give us negative 6 plus 12, which is a positive 6 when we add those together. Now I need the magnitude of the vector u. So its initial point is at the origin, its terminal point is at this component piece right here. So the terminal point is at the point 2, 3. So if you look at the distance formula, it's x sub 2 minus x sub 1. X sub 2 is going to be this 2, and then you'd subtract 0, which would be your initial point. So it's really just going to be 2 squared plus 3 squared. And so we're going to end up with the square root of 4 plus 9, which is the square root of 13. Likewise, when we look at vector w, we're going to have negative 3 squared plus 4 squared. Notice this squaring of a negative is going to give you a positive back. Watch for sign errors to occur there. So we're looking at 9 plus 16. So looking at the square root of 25, which is going to give us a nice integer value here. This is a Pythagorean triple 3, 4, 5. So now that I have these calculations done, I'm going to start plugging them in here. So cosine of beta, I have in my numerator the value 6, that's the dot product of the two vectors, and then in the denominator I need to multiply the square root of 13 and the integer 5. This is a product here. So now that I have this value, I need to take the inverse cosine of both sides. So this is something that you're going to plug into your calculator, and you should know if your answer is expected to be in degrees or radians. So that's something that is going to be based on the problem, the textbook you're working with, whatever your teacher or professor says the expectation is. Since we weren't told at the beginning, this answer is going to be in radians. My calculator is going to be in radian mode. So make sure that you have your calculator in whatever mode you need to be in to make these calculations. Make sure that you are always careful with parentheses while you type this in your calculator. In radians, it's approximately 1.2315, and I went ahead and did degrees also for those of you who want to see what this turns out to be in degrees. It's about 70.6 degrees. And so that's the angle between the two vectors that we sketched up here.